Hi there, this is Kristen Rossler to go over, I think we're on week 9 of BIO1016. It's the microscopy lab. This is actually usually a really fun lab. It's kind of twofold goals. One is to get them comfortable with using microscopes properly, and the second goal is to either look at some cells under a microscope for the first time for many of them, and then the other goal really is to look at mitosis and meiosis. Generally, the lectures have not gotten to mitosis or meiosis at this point of the term, unfortunately, but we're close to it. So hopefully, so the students will have just a, very little understanding actually of mitosis and meiosis unless they had it in high school. So just, be understanding. So anyway, I know, I'm sure all of you have used microscopes before. I just want to kind of go over a couple rules. We want to make sure that the students are holding them with 2 hands. So luckily right now I think the microscopes are out, but if they do need to pick them up from where they're kept, make sure that they have a hand on the neck and on the base. And then they would, of course, bring them to their lab benches. And what we always want to do when we're either starting or finishing with our microscopes is to make sure that the stage is at the lowest point, and also that the lens is on the lowest objective lens. So for instance here, obviously the lowest, this is moving the stage up and down, so we want to make sure it's at the lowest point. So just remind them, especially at the end, that they need to have that all the way lowered, and as well as have the objective lens on the red one, the 4X lens, so that it helps actually with the storing them. So if it's too high, they can jostle around a little bit and hit the stage or whatnot. So we try to keep them like this. All right, so I'm sure you've taught how to do microscopy before. I usually, this is the way I do it, and take it or leave it, whatever way works best for you. I actually start them off making up their own slides here. I usually, the one I always start off with is actually I ask them to get a piece of their own hair, right? So just to grab a little shedding hair that they might have. I usually have some dog hair on me if they want to use their own pet hair that might be on their clothes. That's fine too. They can usually see it pretty well. And then I just have them put a little cover slip over it, right? And so then finally I found one. Actually, I was trying to find a piece of my hair and I couldn't. So let me just go ahead and do that, right? Sometimes, students get a little creative. I've had some students, and I encourage it a little bit. If there's 2 different people sitting next to each other, they can do 2 pieces of hair and have them intersect. I think the reason why hair works nice is everybody can, they can see it pretty easily, and then we can see it on the microscope pretty easily. So of course they would bring this over here, they'd put it on the lowest objective lens, and I always have to remind them that when you're starting off with a microscope, you want to start off at the lowest level of magnification first, and then work your way up to more refined levels. I tell them it's kind of like Google Earth, right? If you were trying to find your house on Google Earth, you wouldn't immediately just, be on land. You would start off probably from outer space, then you would find North America, then you'd find your state, then you'd find, your area, etc. So you're kind of slowly moving in to a more centralized point, and that usually works well explaining why we do this in microscopy. All right, so you probably know that once you find it on the lowest objective lens, then you just immediately are going to, you can go up very easily then to the higher objective lens, so that you're in the ballpark of what is in focus. Yeah, so that usually works well. All right, so once they find their hair and they ooh and ah over that, we kind of move up. So one thing that I sometimes do is get them to make another set of slides themselves. One thing that you can do, you have 2 options or a couple options if you want, or you don't have to do any of these, is you can have them do their own cheek cells, right? So if they're going to do their own cheek cells, what you would do is have them take a slide, obviously, and you've probably done this before. We put like just a drop of water. Let me see if I can get this without just and then we use one of the clean toothpicks that's over here, and they would use that to kind of scrape just a little bit of their cheek, on the inside of their cheek, right? So just a little scrape. We don't need any blood on this. And then they take their toothpick and rub it into the water, and some of the cells are of course going to slough off. And then they can use the methylene blue that Tracy has kindly put out for us. Just 1 drop ought to do it. And then they're going to put the cover slip on top of it, and they should be able to see some of their cheek cells. And of course, epidermal cells are really thin and flat. They look like little pancakes, and they'll be able to see the nuclei. I like to go over how methylene blue is using copper, which is positively charged, and of course is attracted to the phosphates that are on the phospholipid bilayer to attract it. So they can see, again, the cell membrane and also the nuclei, which are, again, a lot of phosphates in the phosphodiester backbone, and again, why the copper kind of specifically stains the nuclei nice and dark. All right, so that's always a fun one. Something else that you could do if you wanted to, if we have availability, is use the Elodia. Now, our Elodia today is not in good shape, so I'm not going to be doing that with my class, but if it is in good shape and you have it available to you, they can just take one little leaf of the Elodia, put it on one of these glass slides, and then just put, again, the cover slip on top of it. And then it's actually a great one. I wish we had it for this next week, unfortunately, but our Elodia you just saw is all dead. But if it is available to you, I will highly encourage you to use it, because we are in photosynthesis right now in the lectures usually, so it's really nice for them to be able to see the chloroplast and all that in its splendor. They can even use, if you feel comfortable, you can have them use the oil immersion lens, of course the 100x objective lens, if you think they're ready for it, and you can take them through the steps. But again, otherwise I try to avoid them using the oil immersion lens unless it's really super warranted and you think that they can handle it, because they have a tendency to put the oil on all the objective lenses. All right, so anyhow, so we usually are just trying to get them comfortable. I usually just show them a couple things, and again, if I had the plant, I would show them the plant, and sometimes we do the cheek cells. All right, so when they're actually ready today to do more of the quote-unquote experiment that we have, what we're going to be doing is there are slides that each student can have that have an onion root tip that has been prepared and stained so that we can see the mitotic process in a lot of detail. I dare say you've done this before. I usually pull up a picture of one that looks really nice before they even get started, and I'll do that right now. All right, so I just found an example of usually how I start them off on this. So I just Googled onion root tip mitosis, and if you scroll through the images, you'll usually find one that kind of looks like this. So it's kind of phallic looking. And I tell them this is kind of what they're going to start looking for. So they're going to be looking, there's 2 onion root tips on each of the slides that they're going to be having. And again, they've been treated so that we can see the nuclei and mitotic cells really nicely. And when they are looking into, they're going to pick one of the mitotic root tips to kind of investigate, right, to look at in detail. And it's going to look like this as they go up into higher magnification. And where they want to focus, and you probably know this, is the zone in which mitosis is actively occurring, and it's going to be right in here. So more of that darkly staining area. Of course, we're seeing the nuclei, the DNA material kind of very nicely in that zone. So that's more of the mitotic region, all right? And when they look into that mitotic region, they're going to start seeing, again, cells that kind of look like this. That's actually, let's find one that's a little bit more representative of what they'll see. It usually looks really nice. Let's see, they might get to this point. That looks pretty good. And then, so what I have them do, if they can find an area that looks like this, is that I tell them to take a picture of it with their cell phones. Now this is the harder part, and let me show you. I think you've probably done this before, but I had not. So I'm going to show you how I tell them to do it. So I've got it kind of on low magnification. Sometimes it helps to have a partner, and they're going to take their phone and they're going to find the white light and go towards the white light with there, we're starting to see it, right? And this is actually on pretty low magnification, but I would just have them grab a picture then at higher magnification of that area, all right? So they're usually able to get a pretty good picture. So I'm just gonna do that for myself real fast, go up to higher magnification, and we'll take the picture. Go up a little bit higher. So I usually get them up to the 40x. You'll also want to remind them not to have the light too bright. They have a tendency to want to blind themselves. So obviously try to avoid blinding. I guess the university frowns on that. Ha ha ha. Let's see, here's a good spot. And again, if one of their root tips is not great, they can go over to the one next to it and try that one. All right, let me turn up the light. All right, so if I was going to take a picture of this one, you can see it a little bit more clearly. And sometimes I go around and I help them hold it. All right, so that's actually looking pretty good. And so I tell them to grab a picture of that. And now they can zoom in on their picture that they took on their phone to determine how many cells are at prophase, metaphase, anaphase, telophase, or interphase, right? So if you look at the lab report, they're actually going to have to count about 100 cells worth, right? And again, we tell them it's not a perfect science, obviously, we're doing our best. But they kind of zoom into their picture and they're going to count about 100 cells that are actively undergoing mitosis. And they're going to quantify, again, which ones are in interphase, which ones are in prophase, which ones are in metaphase, anaphase, and telophase. And again, I'm sure you had to do a similar type of experiment when you were in college. But this is what I show them to start off with. I show them kind of a perfect example up on the board. So I'll Google it, and let me find one that's really kind of beautiful. Which is the one I use. This one. I like this one. All right, so you can see why this is such a great example picture to start off with, is because we have, probably somewhere on the order of almost 100 cells, and we can look at them very cleanly and count them one by one. So first I say, okay, let's look for an example of interphase. And you guys know that interphase is going to be that the nuclei are not very prominent. All right, mitosis has not really begun in earnest. All right, so we're more in that preparatory phase. So for instance, over here, these cells over here, right, we can see that the nuclei are not super duper visible. This one's also an interphase here. And so we would quantify these as like interphase, right? And then they're going to learn, of course, that when the cell starts to actively undergo mitosis, of course, we're going to go into prophase. And now prophase, the big difference, of course, is that the nuclei become much more noticeable. The nuclear membrane is going to start breaking down. And so like this is a nice example, I think, of prophase. This is a nice example probably of prophase over here as well. Yeah, so you can start to see the big difference. So that's a nice prophase one as well up there. So I just try to show them one really good example of what they're looking for. Metaphase, we're going to see, of course, the nuclear membrane is completely disintegrated. We're going to see the chromosomes on the middle of the spindle plate. Right there is a good one. And then anaphase, of course, they're going to be separating. So here's more of a later anaphase. This is more of an early anaphase. This is a really fun anaphase one, right? Towards the end. And then finally telophase. Telophase is that they're very much starting to separate away from one another and form new nuclear membranes. So in looking at this one's a really good telophase. This one's getting close to telophase, right? And yeah, and this one probably just is at the end of telophase, beginning of cytokinesis. So I try to just show them one good example. Another thing that I'll encourage you guys to do, maybe if you want, is to show them a video of active mitosis in action. So if you want, you could just Google mitosis. Sorry, I'm trying to do this one-handed. There we go, mitosis. And I think I use a lily. If you Google like mitosis lily, YouTube, whatever. Let's see if it pops up. Yeah, this is usually what I Google real fast to find it. So it's a lily that's been visualized to undergo mitosis, and it's actually pretty great. And so they like this. And so we talk about that this is already in prophase to start off with. And again, how do we know that? Is that the nuclei are very, very visible, or the chromosomes are very visible. But we can still see, again, there's a bit of the nuclear membrane keeping it enclosed. So this is, very early on that the nucleus is still intact. And of course, what we're going to see as prophase continues is the nuclear membrane breaking down. So I kind of show it to them. So we're going to see that nuclear lipid, that nuclear membrane disintegrating. And we're going to start seeing that the chromosomes now are going to start, oops, that went really quite fast. Let's go back. They're going to start aligning on the middle of the spindle plate. Let's see, where are we? Yeah. All right, so they start to align quite quickly on the middle of the spindle plate. And then we're going to very quickly see them going into anaphase. If you blink, you'll miss it. Whoosh. I get a kick out of that part. I still get a kick out of that part. And then we're very quickly going to start seeing telophase and cytokinesis. Right here is the vesicles starting to build up in the in between the two cell walls that are forming. All right. So hopefully that helps. There's a bunch of stuff online if you wanted to look for it. There's actually a lot of like real-time mitosis cameras. There was one I found once upon a time. It was kind of cool, and I've used it a few times. That showed cancer cells compared to a normal non-cancer cell, and how much faster, of course, the cancer cells grow. So yeah, if you look around, you'll probably see a lot of fun stuff. Anyway, so what we have them do is we have them do a count, again, of the different cells on their picture that they took that are in the different phases of mitosis. All right, and once they do that, they're going to put that into a little table. Let me show you that.